Welcome to the Explainer. Okay, today we are not just doing some dry, boring anatomy lesson. No way. We're doing a complete structural teardown of the ultimate biological fortress, the bones of the human thorax. Think about it. This is the dynamic cage that literally keeps your most vital organs safe, all while expanding and contracting millions of times over your lifetime just to keep you breathing. It's an incredible piece of engineering.
So here is our game plan for the teardown. We're going to start with the dynamic thoracic cage as a whole, then look at the sternum, check out the ribs, and examine the thoracic vertebrae. After that, we'll get into the actual mechanics of breathing, and finally look at some clinical anomalies. All right, Section 1, the dynamic thoracic cage, an osteocartilaginous elastic cage. To really picture this cage, imagine a truncated cone. It's narrow at the top, broad at the bottom, and made up of bone and highly elastic cartilage. But you know what's really fascinating? How its shape actually changes. If you look at infants, specifically under the age of 2, we all start out with a chest that's completely circular in its cross-section, but then gravity, posture, and normal development take over. By adulthood, that chest flattens out and becomes reniform, or basically kidney bean shaped, meaning it is wider side to side than it is front to back.
Section 2, sternum, the dagger, or the front handle. Right at the very front of our fortress is the sternum. It's that flat, centrally located bone right on your anterior chest wall. And honestly, the best way to think about it is like an ancient dagger. It's about 17 centimeters long and breaks down into 3 distinct pieces. At the top, you've got the manubrium, which acts as a really thick, sturdy handle. Below that is the longer, narrower body, that's the blade, and right at the very bottom, it tapers off into the cartilaginous xiphoid process, which forms a sharp little point.
Now, if we travel back up to exactly where that manubrium handle meets the blade of the body, we hit one of the most absolutely crucial landmarks in the entire human body. It's called the sternal angle of Louis. It's just a slight ridge, maybe 5 centimeters below your neck, but it acts as the ultimate roadmap for your chest geography. Seriously, trace your finger laterally from it, and boom, you instantly find your second rib, which lets you count all the rest. Look deeper inside, and it marks the exact spot where your trachea splits. It's where the massive arch of your aorta begins and ends, and it perfectly aligns with the disc between your 4th and 5th thoracic vertebrae right in the back. Section 3, ribs. The protective arches are curving levers. Forming the sidewalls of our biological fortress are 12 pairs of these dynamic curving levers. The top ones, ribs 1 through 7, are called the true ribs. They are securely fastened from the spine directly to the sternum, using their own costal cartilages. Moving down, ribs 8, 9, and 10 are the false ribs. They don't quite make it all the way to the sternum. Instead, their cartilage kind of piggybacks onto the rib directly above them. And finally, ribs 11 and 12. These are the floating ribs, which are exactly what they sound like. Free-swinging levers in the back with absolutely no attachment in the front. Let's zoom in on a single typical rib for a second. If you were to run your finger right along the inner, lower edge of a rib, you'd feel a sharp drop-off. That is the costal groove. The really crucial takeaway here is what actually lives tucked inside that groove. Just remember the mnemonic vein, V-A-N, going from top to bottom, vein, artery, nerve. That sharp bottom edge of the rib forms a perfect little overhang, protecting those highly sensitive intercostal vessels and nerves from outside trauma. It's just brilliant design. Section 4, thoracic vertebrae, the back anchor. Okay, moving to the absolute back of the cage, we find the stabilizing central pillars. We have exactly 12 distinct thoracic vertebrae, which perfectly matches our 12 pairs of ribs. A typical thoracic vertebra is unique because its body is heart-shaped, but the real engineering marvel, that would be the costal facets. These are tiny, smooth little cup-like depressions on the sides of the vertebra and its transverse processes. They are precisely designed to lock the back heads and tubercles of the ribs firmly into place. The result? Joints that are incredibly stable, yet still allow for pivoting. Section 5. The mechanics of breathing. Form meets function. Up to now, we've just looked at the static pieces, the handle in the front, the levers on the side, the anchor in the back. But as the saying goes, anatomy is just geography until it moves. Memorizing the bones and grooves just sets the stage. The true miracle of this whole osteocartilaginous setup is thoracic respiration. The moment you take a breath, the geometry of this entire cage fundamentally shifts to literally suck air right into your lungs. When you inhale, your ribs act as levers, taking these tiny little movements at the spine and magnifying them into a massive expansion of the chest.
Picture a classic water pump handle. Because the front of a rib sits naturally lower than the back, when those upper ribs elevate, they push the sternum up and forward. Just like pumping that water handle, this drastically increases the front to back diameter of your chest. At the exact same time, we get the bucket handle movement. The middle parts of your lower ribs swing outwards and upwards, literally exactly like lifting the curved handle of a bucket. This pushes the side-to-side diameter way out, creating the vacuum that fills your lungs with air. Section 6. Clinical anomalies and injuries. Structural failures.
Now, to ground all of this flawless architecture in reality, we have to look at what happens when the machine gets hit with immense force, or when there's a tiny typo in the genetic blueprint. A rib is an amazingly flexible lever, right? But it definitely has an Achilles heel. About 5 centimeters from where it attaches to the spine, the rib takes a sharp outward curve. We call this the angle. Because of the physics of curved bones, this angle is structurally the weakest point. So in a severe crush injury, this is almost always the exact spot where the bone will fracture and ultimately fail.
Sometimes, though, the structure doesn't fail from an impact, but just from how it developed. Take funnel chest, for instance. This is a common clinical anomaly where the sternum and those attached costal cartilages are abnormally depressed inward. It literally creates a cave-in, looking just like a funnel right on the front wall of the chest. And then we have the direct opposite condition, known as pigeon chest or pectus carinatum. In this anomaly, the upper sternum and its cartilages project sharply forward instead of inward. It flattens out the sides of the chest and really mimics the aerodynamic protruding keel that you'd see on a bird's anatomy.
Okay, I want to wrap up this clinical section with a surprising, kind of humorous anatomical fact: the gorilla rib. Believe it or not, occasionally a human will just sprout a 13th rib. Seriously. It's an accessory lumbar rib that grows out from the costal element of the very first lumbar vertebra right below the normal 12th rib. It's almost always completely symptomless. Usually it's just a fascinating little echo of our broader evolutionary biology that randomly shows up on a routine X-ray.
So as we close out today's explainer, I really want to leave you with a thought. Your chest is an absolute masterclass in biomechanical engineering. It's a flexible cage that is going to expand and contract millions of times throughout your life, tirelessly protecting your heart and lungs. But as we've seen, it's not invincible. It has vulnerabilities, weak angles that can snap, and cartilages that can deform. Understanding the architecture of your own breath is the first step in truly appreciating the miraculous machine you live inside every single day. Keep marveling at your anatomy, and we'll catch you in the next explainer.